Hey everybody, how's it going? Bo here with Tech Talk Live. I'm going to bring our good buddy Troy in here and waiting for him to roll on. Don't see him yet, but we are really excited for today. We have a really cool show for you today. And as soon as I see our buddy Troy, and look, there he is. Bring him in.
Hey.
How you doing?
Good. How are you, brother?
Good to see you.
Good to see you, man.
Yeah, no doubt. I'm on speaker and I don't know why, so I'm going to try and fix it. So I might screw this all up. Oh,
hey, no worries.
There we go. Good. All right.
You're good.
How we doing today, Troy?
Perfect.
How's things in the lockdown garage?
Whew, I'm gonna try to bring my A game today. I have a cold, and it is a cold. Don't worry, it's nothing beyond that. But it's congested. It's kicking my butt. So I'm gonna try to bring on that A game. I'm all hopped up on Sudafed and Mountain Dew, so I'm ready to rock.
I have a really simple cure for this, Troy. What you want to do is you want to switch out your beard balm to Vicks Vapor Rub.
Oh,
awesome.
That's a good idea. I like that. Smart man,
Yeah.
Smart man. That's why you get paid the big bucks.
Your wife might not appreciate it, but you know what? That's all right. You know, it's while you're in the garage. It's good. It's good. You got to watch the sawdust sticking to it, but you'll be good.
Yeah, exactly. Nice. I like that idea. I might, I'm crazy enough to actually try that. You know what I mean? Because
yes, you are.
Man, right now, I'm telling you, but it's all good though. It's good. It's been a good week. The weather is perfect in New Hampshire. We are in a bit of a drought though because it just won't rain. It hasn't rained in a while. So, but
wow.
I like this weather though. So and I have a drilled well, so I'm not too worried about it. It's still a concern, but I have a 465-foot drilled well with 500 gallons of water. So I'm hoping I'm okay.
Well, hopefully you never have to pull that sucker.
I didn't, but when I bought the place, the well pump burnt out because this place was built in 1984. So, all of a sudden I lose water. I know exactly what it is. I troubleshoot it. I don't have the equipment to pull it. So I call up my buddy, say, hey, bring your truck, bring your pump. You got it. And he has all the equipment. He has a truck with a boom lift that pulls them, right?
Got an easy up, yeah.
Oh, yeah. So they did that, and he's like, dude, this thing is 465 feet deep. He's like, you got 500 gallons of standing water. The recovery rate is not good, though. With a well system, you want about a 2 to 5 gallons per minute recovery rate. I have a 1/3 gallon per minute recovery rate, so that's not good. But
maybe you need a cistern.
Maybe.
You got time on your hands. You can put one of those in. Just slap one in. Come on,
Absolutely.
So what are we talking about today, Troy?
I'm excited today to talk about residential plumbing solutions. So for everybody that joined, there's some really cool plumbing solutions, residential and commercial. I mean, to be honest, a lot of the stuff is transferable, but what we're going to focus on today is some residential plumbing solutions that Viega offers. And, we offer 3 different styles for installation. We don't just force you to one way or the other to sell a product. We actually have like what we call a 3-2-1 method. And so we have 3, installation methods, meaning we can do a branch and T, we can do, a combination of branch and T and manifolds. And then we have our home run ManaBlock, which everyone sees right behind Bo, which looks fantastic. That's a beautiful install. That's how one should look, right? And that's what we want to get into. We want to get into these methods and why you do one versus the other, kind of debunk some myths that are out there because, right off the bat, and that's why I wanted to do this episode because I love just stirring things up sometimes. But right off the bat, when somebody sees one of these posted, the ManaBlock, a lot of times, yeah, there you go. That's the reaction. I get, oh, that's garbage. I don't like those. They don't work. They're awful. The truth is they're actually a great product, but you have to design and install them correctly. That's the reaction, right?
Yep. That's
it. Man. And that's just it. And the truth is like that's why we offer 3 different solutions because we have to look at the layout. We have to look at the application. We have to look at the end user, the customers, needs and wants. Like, what are they looking for? How is their house set up? What's their daily life like? right? Like, what's their annual usage? What's their daily usage look like? Like, what's going on? Like, what's their expectations? And we have an entire design team that does plumbing for residential and commercial. They do 13D residential fire sprinkler. They do radiant heating and cooling. There's a whole design team back at Viega. They're actually housed here in New Hampshire. And if you ever need their support, and we'll make sure maybe we'll type in a comment here where their address is. But if you ever need support from design, the email address is simple. It's design@viega.us. So if you ever need design assistance, please get with them, because that's how they're going to allow you. They're going to be able to look at that print. They're going to be able to work with you to find out what that customer's demands are, what those customers' needs are, and they're going to be able to design a system for you. Because just putting a ManaBlock in the basement next to your water heater and call it a day is not the right application, right? But I mean, you see it all the time.
Absolutely.
So
yeah, and what we hope to get for you today is to help you set expectations with your customer so that you can add value to what you do. Again, Troy and I like to bring value to you. We don't want to bring you down. We want to lift you up, give you more options, give you things to work with. And when you can set expectations, suddenly you become the pro, and they're going to want to do business with you no matter what. And that's really the important thing, is you're adding that value. So, and having that design services element behind it, like not only did I select the right product for you, but I had the manufacturer help design it, so you know you're going to get a system that's going to perform.
Absolutely. And I know we got a great, we got a great list of things to cover today. And a lot of that is what design service looks at. So pay attention to a lot of things we cover today, because design service is going to look at that. They're going to lay it out. They're going to see if you need hot water recirculation. They're going to size the piping accordingly, to your demand. What's the gallons per minute needed? What's the velocity? What's the flow? Pressure coming in, pressure to the fixture. What do the fixtures need to pressure to operate? And they're going to lay that all out, give you an actual CAD drawing with layout, labels, everything. It's professionally done, and a bill of materials. So it's a great service. For residential, they do charge. It's $250 for residential projects. Commercial projects are free of charge. So again, get with design@viega.us, and I'll type it in here later on in the chat so you all remember that. But that's what we're going to be looking at today, is the residential plumbing solutions. And the first one that I want to talk about real quick, and then Bo's going to go into how to properly lay that out. And then we're going to go into some other joining methods and things like that. We have plenty of things to talk about today within this 60 minutes. But I want to just pull the ManaBlock up front real quick and talk about this, because if all of you saw the teaser that I did about the electrical panel with the ManaBlock, that's really kind of cool. It's what it is. It allows you to have individual shutoffs, and you can actually, it comes with stickers, so you can label it just like an electrical panel. So I could say that this is a kitchen. This is a bathroom lab. This is the master suite, whatever it may be, the outdoor silcock, hose bib. And you can label these all the way down. And these come in various sizes. This is just a demo. So when I open this up, you'll be able to see through it. But they're a solid black, plastic block. Each piece is, manufactured. I'll show you that. And then they're stacked together. So these blocks you can actually get in 14 port, 18 port, 24 port, and 36 port. What that does is depends on how many hots and how many colds you need for that project. And with design services, what they're going to do, they're going to let you know if you need more than one, because Bo's going to talk about this today, which is great, and I love it. We're going to talk about hot water recirculation. Sometimes you can't, again, I said this in the earlier show, you can't just put a ManaBlock next to the water heater and run these lines 350 feet across a mansion, a McMansion. That's not going to work. That's where things get a bad name. So you want to make sure you install those correctly. But everything's going to come inside the box with the mounting. So what comes inside the box is the supply right here, or your distribution, connections. So those are to go out to the fixtures. And those could be 1/2 inch or 3/8. That's how you order this. And we'll get into that as well with 1/2 inch and 3/8 debate. But they come with, you order them with 1/2 inch or 3/8. And those connections come with it. The supply connectors on top and on bottom to feed this or to feed your water heater, those are sold separately because we're not sure exactly what size you need. So this happens to be 3/4. I got 1 inch right here. We got different connection methods for the top, whether you have a threaded adapter, a compression adapter, a PEX press, a PEX crimp. So there's various, that's why they don't come in the box, because I don't know if the rest of the building is CPVC. Is it copper? what am I, or is it all PEX, right? Okay, so that's why we want to give you those options. So just keep that in mind that the supply port adapters, top and bottom, do not come with the ManaBlock because we don't not sure which ones or what size you need for that block. And don't use a regular female adapter. Ask me how I know, Bo.
Yep. You need the port adapters and the supply adapters.
You need them. And the reason for that is you're not going to tape and dope these threads. You're not going to put tape and dope on here. These are not your traditional tapered, national pipe threads. They're not relying on the threads to make the seal. You're relying on the fitting to make that seal up against the block. So actually those adapters are only go on hand tight with a little quarter turn. That's it. Hand tight, quarter turn, and that's it. You don't want to crack the block because it's plastic, right? You don't want to rely on the threads to make the seal because plastic threads, in my personal opinion, are garbage. So that's why we're not relying on the threads to make the seal because it's plastic. So that's why these adapters for the ManaBlock are important that you get the right ones. But again, the side ports come with the block. So the hot and cold distribution lines, those adapters come with the block. It's just the supply ports that do not. So just keep that in mind. All right, let me open this up right here, Bo, so everybody can see what the insides of the ManaBlock looks like. There you go. Nice. See-through.
Nice.
So this is what it looks like on the inside. Now, again, this is a special marketing block that was made for us. They're black blocks. You can't see through them. And you can see there's nothing really in here. There's no diverting valves in here. There's no baffles. There's no screens. It's whatever goes in comes out, right? That's all it is. It's a distribution manifold, right? So there you go. So each section is actually manufactured at the plant. So this is what is manufactured, something like this. This is what's stamped out in our Kansas manufacturing plant. Then we put the sealing elements right there, those red sealing elements. We put in the shutoff valves on the inside, right? So then they get assembled like this, stacked together and compressed, right? So depending if you have an 18 port, 24, 36, 14, whatever it may be, they get stacked together, compressed. This is riveted like a shaft that's riveted on the top. So you can't take it apart. The block is not serviceable, right? The only thing that's serviceable is the shutoffs, just like any shutoff, right? The shutoffs are serviceable. They are replaceable. And we can always get into that in another chat, and go through. And maybe I should even do a video on how to replace these if need be. So that's what it looks like. And the operating pressure of these blocks, the max operating pressure, this is going to be 100 PSI. So if you ever see a photo of somebody with a pressure reducing valve coming in before feeding the block, there's a reason for that. That's because max operating pressure is 100 PSI, and there's roughly a 3 times safety factor built in. So I tested it myself. I want to see where it would blow up, and it will actually separate these chambers if it's over pressurized. And that's, again, roughly a 3 times safety factor from that 100 PSI. And that would separate these blocks and cause a leak. And that's some troubleshooting and service work that I used to do out in the field is if this block is over pressurized, or if this ManaBlock is in a garage that's unconditioned, which I've seen, it freezes, the water expands, it separates these, and blows it apart. So then it starts leaking right through this section right here. One of these sections will give, right? So those are the thing. That's why, again, proper design and proper installation is key with these blocks, and you won't have a problem. These blocks have been out since the 70s. And there's homes that still have polybutylene ManaBlocks that are operating perfectly fine with no issues, no leaks, anything like that. Again, as long as it's installed correctly. So those are the things you want to look for. And this is your ManaBlock right here. Again, get a design done, talk to us, get a hold of me and Bo. We'll walk you through and tell you how to do it. But I've done a few of these myself in some condos and some projects and higher end condos on the lake. Up in Lake Winnipesaukee, and they've worked fine, and they've been in for 12 plus years, no issues. And again, it's because we designed them correctly, we installed them per the manufacturer's recommendations, and there's been no issues. So the issues I always see is just somebody doing something that is not allowed. So just keep that in mind. That's like any product, right? So you abuse it, you don't use it right. When I abuse my truck and I blow the transmission up or pop a piston, that's my fault, right? So.
Awesome. One thing to point out that Troy mentioned is, with the 3 times safety factor and the maximum operating pressure, if you have a ManaBlock or anything in a plumbing system that blows apart, not due to freezing, but due to pressure, you have a much bigger issue. think about your water heater T&P relief valve, 150 PSI, right? So if that's not opening, you've got a big problem. You've got a hot water bomb in your building. So you need to think in those terms. So Dan Holohan used to say, well, actually it wasn't Dan Holohan, it was actually Al Levi. He said, the problem and the solution are rarely in the same place. And that is so true for you all out there doing plumbing troubleshooting. Sometimes it's not where you're standing. The problem could be somewhere else. So think in those terms when you go in to approach a project and what you really need to consider when you're putting one of these systems in, or another type of system. Could be branch and T, could be a multi-port T system, or a combination system. We're going to touch on that too. So those are things you need to kind of think about.
No, absolutely. No, perfect. And Bo, I know you got a lot of different installation in your workshop there, which is nice. And so what do you want to roll in through first? I'm ready to talk about anything. I hope we get some good comments here.
Well, let's just take a look at the ManaBlock, and I'm going to zoom in here a little bit on it if I can. And I'm going to get my ugly mug out of the picture. And I'm just going to step to the side here, and hopefully you all can see me. So we have a ManaBlock installed. It's installed on the mounting straps. You can purchase the mounting straps. You could put plywood behind the wall. Depending on where your manifold's going, you can get creative on how you want to mount this. We do have some galvanized mounting straps, and they're really sturdy. They lock the ManaBlock in place. So we wanted to use all the Viega products so you can see what we're talking about. But as Troy mentioned, this is also a special block. It is a clear and black plastic ManaBlock, so you can see the clear chambers. Interestingly, little fun fact, this plastic, the actual resin that we injection mold the ManaBlocks from, starts out as a clear resin, and then carbon is added to make it black. And you don't really want to see the sediment that's going to build up in any plumbing system. Anyone who's opened a piping system other than PEX, even PEX eventually may have a little sediment on it depending on what your water quality is coming in. So we make them black. But this is the ManaBlock. You can see the sealing elements between the ManaBlocks are the red sealing elements, and then each one of these connections has a sealing element in it. It's a static seal. It's not in the flow path. It's locked into place. There's no water contacting it. It's totally sealed. And of course you have your PEX connections, and we offer them in press and crimp. So we have them in bronze and plastic connections. So depending on what your flavor of the day is, what you prefer to work with, we can accommodate that for you, because we know there's a lot of differing opinions about polymer fittings versus bronze fittings. Some people like bronze fitting systems, and that's perfectly fine. We have those as well. So you see the ManaBlock. These are the port connections that Troy talked about, and they are also a hand-threaded connection with a sealing element, and then these are the polymer press versions. And basically what we have is our cold water coming in and feeding the block down here. And I'll just, you can see it. So we got a little shut-off valve here just to isolate the block. That can be, at your main, or you can put one in at the block depending on how you want to pipe the system. This is a demo. It's a live demo. It actually has water in it. It's pressurized right now. Under building pressure, it's sitting at about 50 PSI. And we use this in training when you come to the seminar centers, and there's one in Nashua as well, and you can pipe it up and connect it up and so forth. So the other thing to see here is you've got a blue line leaving the ManaBlock, and that is feeding our water heater, which is back here, and I'm going to show you that in a little bit. And then coming back from the water heater is our hot line, which is feeding the hot side ports of the block. So that's basically the layout of the distribution system. It's a large 1.25" diameter chamber, so very low pressure drop, almost none through the block. So you get parallel distribution. So the only drop that you're really dealing with is from your supply to your block, which is going to be larger diameter pipe. In some cases, when you're designing a residential project, you may be up to 1.25" on your lateral with PEX. It just depends on what kind of incoming water pressure you have, so forth and so on. Like in Troy's case, he's got a well. He's working with a fixed amount of pressure. Here in Colorado, we have ridiculous pressure at the curb. So typically, because we have people in the foothills, we have forced mains, so you'll see a low of 80 PSI. In a lot of cases, we can see over 200 at the curb. So we always have to reduce down. If you remember, code says your water pressure is limited to 80 PSI inside the building. That's code. Also, whenever there's a fluctuation in water pressure or you're over the maximum water pressure, a pressure reducing valve is required. And we're going to get into expansion control in a minute, because that's another critical component to good plumbing design. And it's also a good value add for you when you're troubleshooting or designing a system. So we'll cover that too. So that's
Bo,
yeah.
I just want to, there's a good question that somebody just popped up here, and there's something else I want to talk about, because I know I could count on you to do a perfect install. I'm looking at how that block's set up. And I'm seeing the PEX installed from the bottom to the top. And if the viewers notice, there's a few, ports that are unused. That is the right way to do it. You never want to leave any of the bottom ports unused, because when we talk about water quality and you talked about that sediment in a system, whether the minerals, whatever, the manganese, the calcium, whatever is in your water, it's going to settle somewhere, right? So without flow, without flushing, you could get some stagnation and you could then hurt the water quality. So by piping in exactly how Bo did here, and that's why I'm so happy to see this, because I try to train on this every single time, is because if you leave the ports at the top unused, which is perfectly fine, because like I said, 14, 18, 24, 36, that's how they come. So you may have 1, 2, 4, who knows how many ports unused for future, and you could cap those off. But that's how you want to do it. Work from the bottom of that block up, because that block has a divider plate. That block right here, and actually, I don't know if you can see that, Bo, because it is clear, but there is a divider plate right here. That's where my finger's showing it. That's a divider plate. It's dividing, so make sure the cold and the hot do not mix, right? Because you're always going to have more cold than you have hot. So just think about this divider plate right here. That's the bottom of the block. So my hot water is coming in. It's filling that chamber, that 1.25 inch chamber, and it stops right here. Now, if you only flush from the top and leave this bottom unused, you're only flushing out the top of this ManaBlock, and you're going to get sediment in the bottom here that is unused, and you can't pull that out. So by using the bottom ports first and working your way up, the water is going to flow. So I would say always use your highest demand, most used fixtures on the bottom ports, so it is constantly flushing this block out for water quality purposes. And that's great to see that you did that, because people are going to be doing laundry all the time. People are going to be washing dishes. The dishwasher is going to be running, So your highest demand, most used fixtures, work from the bottom of this block up to the top. And if you have any left over, cap those off. And then we had a great question about, is there any heat transfer, Bo? Right? They're wondering, is there heat transfer? Because you got the hot and you got the cold. Is there heat transfer? Well, if you can see how this block is made, they're actually not touching on the inside. There's actually air gaps in here. So they're not touching. That divider plate is a thick plastic, and again, there's a K factor to that, thermal conductivity factor. There's a thick plastic divider. So we are trying to alleviate, or eliminate, avoid that heat transfer between those two. So no, the block is not going to have any heat transfer with that because of the way it is designed. So great question.
Really good question, and we'll bring that up because I'm going to talk about bundling lines, and there is some requirements for when you bundle lines with regard to heat transfer, so really good segue into that. Something else you may notice is, I don't know if you can see this or not, but we've got 3/8 and 1/2 inch tubing coming off the block. So depending on the type of fixture, depending on what you design for, you may need some 1/2 inch connections to the block. You may need 3/8. One of the cool things about the block is it's a water saving device. The idea is that, and this is a really good way to think about this, and I don't know if we've ever said it this way, but I like to say it this way. And just so you know, I didn't install this block. I can't take credit for it. Tim Severance, senior technical trainer here in Colorado, put this puppy in for us.
Well, I'm sending him my kudos then.
All right, yeah, you did a great job, no doubt. Think of this as your hot water and cold water, but think of it in terms of hot water. This is your hot water source now. Okay, the water heater is simply supplying this with hot water, but the hot water is leaving the block. And the important thing to know about that is when we get to recirculation, this will help you plan installations for where your block goes. Now, the manual says keep this within 8 developed feet of the water heater. Yeah, that's fine. If you're just doing the block, there's no recirculation in the building, okay, or you have a condensed floor plan, 8 foot is plenty, okay? But if we get into a building where we have multiple blocks, we want to recirculate, and this becomes the hot water source. It is no longer just a distribution point, and I'll explain that in a minute. So in a couple cases here, we've got some 1/2 inch coming off, and that's feeding the tub. Now, in a lot of cases, you would still feed a tub and shower with 3/8. It's perfectly fine. It's going to depend on the distance and pressure drop, so forth and so on. We like to keep our fixtures within 50 developed feet. But you can go further. It just depends. Really, that's kind of a rule of thumb where we like to see it.
Yeah, max is 65. Max is
65 is your max.
65.
That's right.
Yep.
The other thing is we've got 1/2 inch here coming off for a hose bib, and it's just a basic, demonstration hose bib down there at the bottom, just to say, hey, yeah, you could run an outdoor spigot off of your ManaBlock. If you needed more pressure, you might come off before the PRV, in which case you're just going to branch off your main when it comes into the building. So it just depends on your design and what you're looking for. But yes, you could pull a hose bib off of this. It's perfectly fine. Sorry.
Yeah, you froze for a second. You're good.
Someone tried to call me and it was spam as usual. I think you got one of those yesterday. We were on the phone. I don't know what it is with spammers right now, but they're really getting aggressive. So
they're home. They're bored at work. They're just home. They're stuck. They're just nothing to do.
Let's call people. So the idea is that when you're using 3/8, and as I said, this is your source, 3/8 contains less water per linear foot. So when I open a hot water fixture, I have less water to dump down the drain before the hot water travels through the line and gets to my fixture. Something else that code says, and this comes up in multiple codes where it's addressed, is using 3/8 for distribution to a fixture. If you're doing a branch and T system, there are no model codes that allow 3/8 to a fixture. I can tell you that. However, when using a manifold distribution system, or a parallel is how it's worded, distribution system, which is what this is, 3/8 is allowed, okay? Because we're only dealing with the pressure drop from source to fixture. So really important thing, because a lot of people are saying, oh, you can't run 3/8 to a fixture, or I don't want to run 3/8, I won't have any flow, I won't have any pressure. That's not true, okay? Under 65 foot, especially usually within 50, you'll be surprised on a typical, average home, you're going to be in 50 developed feet before your fixture anyway. So that's typically what you'll find. So depending on where you locate this. So multiple options for connecting. I've got a laundry box over here that's piped in 1/2 inch. Again, just for example's sake, these are all live. We've got them capped off. And something just to reiterate about the ports that Troy was mentioning, these are caps. So we sell caps for the ports. So inadvertently someone comes along and grabs the key from the ManaBlock, okay, which is actually clipped onto the cover here. There's a little hole to keep your key, and if you lose your key, no problem. We've got tons of extras. We'll send them out to you. No big deal.
We do.
Happens all the time. You can, obviously turn that on, but if someone were to grab the key and turn it on, they're going to spray water in the wall, especially if it's placed in the wall. Imagine that there's drywall over all of this and an access panel here. We also have an access panel, both a fire rated and a standard access panel available for the ManaBlock. So we have all those accessories should you need it. So something else you'll see here up at the top is a 1/2 inch T and branch coming off the 3/4 hot, and then I have a little isolation valve, and this 1/2 inch line disappears into the ceiling, and that is my recirc line. And what I am doing is recircing between my appliance, my water heater in this case, and I'll show you that, to the block. So my recirculation is simply to the block, not through the block. So I don't want to have my recirc connection at the end of the farthest fixture, say 65 foot away, and have a T in the wall and be circulating through this block. They're not designed for that, okay? Our water saving comes in the reduced tubing size. Anything you want to add to that, Troy?
No, I mean, I like you talked about code, and that's a huge thing that our team in tech support covers all the time is code questions, because a lot of jurisdictions, right? I wish there was one standardized national code to make everything just so convenient. Yeah, mind blown.
Get off quick. Get off quick.
Yeah, stop it. Somebody's gonna assassinate me for coming up with this idea, right? People are gonna lose jobs, but it's like, seriously, like, I wish there was one national code that we could cover, because unfortunately there's not. You could actually do a residential. So we're talking about residential plumbing today. You could actually look at doing your plumbing through the International Residential Code or the International Building Code, right? You don't have to use the UPC or IPC in that case. A lot of people don't realize that. The UPC, the Uniform Plumbing Code, the International Plumbing Code, those are really geared towards commercial type applications, but a lot of inspectors and jurisdictions and plumbers, we fall back onto that code book because it's easier to reference instead of having the residential code, because we're not builders, right? Maybe we're not builders, we're just plumbers, right? So we're like, oh, I don't need this huge international residential code for 20 page of plumbing. But you know what? I could actually build homes to that international residential code, and things change. You know, Bo's talking about hot water recirculation. There's different rules and regulations when it comes to a residential code and a commercial code, depending on the developed length of your furthest fixture, of if whether or not you need a hot water recirculation. So look at that. Understand your territory, your jurisdiction, because you know, you could actually get away with saying, hey, no, I'm plumbing this building to the international residential code or the international building code or what have you. So just keep that in mind, because I will tell you in New Hampshire, even though it's in the code that you can do 3/8 and 1/2 inch because it's a parallel plumbing system, a manifold, and there's a picture of Viga's ManaBloc right in the commentary, right? A lot of the inspectors or jurisdictions try to get an amendment or kind of say, nope, 1/2 inch only to that fixture. You know, that's the smallest. So sometimes we can't, unless we get an engineered design. That's where design services comes in. If I can get a design from design services, then the inspector will sign off on it. So keep those things in mind, things you're going to run into out in the field. But I will tell you, in places that are really all about water conservation, you've got Nevada, Utah, California, places like that. We're doing a lot of 3/8 parallel plumbing systems in those territories, doing a lot of designs for them.
Absolutely. You know, something just about design that Troy mentioned, you know, there is a fee for a design, you know, a design of a system, and nothing's free, right? If you want it to have value, you know, there's got to be some cost associated with it, but it's a pretty small cost. But for those of you that are looking at that and saying, wow, $250, I don't even know if I have the job, you know, it's a value add. Actually, you can offer it to your customer and say, hey, if you want to proceed forward, I can have this design for you. It's $250. And if you purchase the job from me, you know what? I'll knock it off the price of the job. I'll put it right in my quote for you. And if not, you can hand the design to them. They can take it somewhere else, but at least they got something for their money, and it adds value because you're not willing to just go, yeah, you know, which is what probably the other guy did, right? Oh yeah, your house fits in my box here, so yeah, you need this system, and you know that happens all the time. So use it as a value add, and the design team is there to help you do that. So we were talking about code and insulation. And, you know, again, heat transfer. There's one thing here that we did that really technically wouldn't fly with the current code, okay? And code updates happen all the time. So to Troy's point, crack a code book every once in a while because you might need to stay updated. And you know what? Look for future code update courses from the Colorado and New Hampshire Seminar Center. In this downtime, we're going to be building some new content to help you just get refreshers as part of your regular training. So we're really tight with our codes and standards department, and they send us regular updates. And Troy is fantastic at synergizing that information so that we can get it back to you. And that's what we want to do. We want to help you elevate. So look for that in the future. But back to code on this, one thing, when you're bundling lines, and one key with a ManaBlock, if you decide it's something you want to install or offer, is to bundle your lines together, especially when you're doing 3/8. So you don't pull one 3/8 line, pull them all in that direction. So if I'm taking, you know, 3 lines over here, 4 lines, I want to get literally 3 or 4 coils of 3/8, depending on red or blue or whatever I'm using, and pull them all through one hole. Now, the key there is when you are bundling lines together, and typically in residential applications, depending on your jurisdiction, you may not have to insulate your hot and cold, okay? Cold we'd insulate for sweating if you're in a humid environment, and hot, obviously, for heat loss. But depending on where you are, it may or may not be required. However, code does say when you bundle the lines together, hot and cold, you must insulate the hot. So keep that in mind. It would be very difficult to do where we just pass through this framing member just to kind of get tubing behind. But if this were an actual inspected installation that we needed for, you know, a residential building, depending on the jurisdiction, this would not fly because it'd be very hard for me to insulate these to code with 3/4 inch wall or 1 inch wall insulation. So keep that in mind. Bundle them together, but if you have to insulate, keep them separate because you're going to need to put Armaflex or whatever you're going to use for your insulation on that. And I'll just pan over. Whoops. Again, the button. I can never get it right.
Well, and that's a great point, Bo, because in our installation manual, we show that you can bundle hot and cold tubing together with no insulation, because that's our manufacturer stance, because we talk about heat transfer. It's not going to transfer that heat, but new energy codes, right? So know your jurisdiction. They're the ones that are now dictating that. So it's not in our manual that says it's the code. So we still have to follow code and adhere to code. We can't supersede that. So know your code and then know what the manufacturer says and marry those two together. So And sometimes,
Absolutely.
again, it takes education, and maybe if it's the design build, there might be some things that could get kind of stamped to say, no, we're good. This was design build. But again, just instead of doing it first, find out.
Yep, absolutely. So in this case, obviously, we're just feeding the tub and shower valve, which is a Lixil American Standard valve body. It has press ends on it so that you can press your press fittings right to it. And we're feeding that with 1/2 inch. So I just wanted to see that that does go somewhere. It goes over to the tub and shower. And yes, that's my non-Tech Talk Live coffee cup over there. I just want to point that out. That's just a plain. It doesn't say Tech Talk Live. I don't know why, but it doesn't. So I just thought I would chuck that out. Okay. Anyway.
Don't worry, I'm gonna get you one. Don't worry, I'm gonna get you one. All right? I know I teased you with it.
The Eagle T-shirt that I haven't gotten used, so it's fair game because
this is my old one, so I haven't got you. Yeah, you're right. You had those first. This is my old one that's ripped and stinks. You know what I mean? I've had this for 10 years, 9 years.
Yep. So last thing is we've got some 3/8 running across here, and that's just feeding an ice maker box over there in the far. All the way over there we got an ice maker box, and then this we're just set up for a lav here or a laundry tray or whatever, just to show basic plumbing. And obviously this is condensed. We're not going to have all this in a building, but it's a demo. But the idea is this is real working situation that you can apply the ManaBlock system to. So any questions about the ManaBlock, feel free to go ahead and enter them into the comments. With that, what about other installations other than ManaBlock?
Well, I know, Bo, and I know, listen, hey, you and I both love the ManaBlock, and we've put it in. There's another manifold that Bo and I really love, and it's the TechXpress Radel R manifold right here. They come in 1/2 inch ports, right? And you can get them in 3/4 inlets, 1 inch inlets. Something. There you go. Look, yeah, see, different configurations.
Bigger, Troy.
Yeah, thanks. I got manifold envy now, right? So one thing though, on mine here, I have these clips. These clips don't come with it. Those are actually PEX tubing clips that I use, and this is how I mount that manifold. So it's nice. So use these PEX tubing, snap clips, touchdown clamps. And that actually holds this block, this manifold in place somewhere, whether it's on a joist stud, plywood wall, something like that. But I like these because you can actually flow through. So, Bo, you mentioned not to do hot water recirculation through the ManaBlock directly through it, right? You do it before it. But you know what's cool about these is I can actually go through this manifold and do 24/7 hot water recirculation. So you're kind of doing like a multi-purpose system, meaning or a branch and T / manifold type system. So again, this is another design that Viega will do for you in design services. And I do like this way as well. So again, depending on the layout of the building, am I going to do multiple ManaBlocks, or do I only need one ManaBlock, or do I need multiple with a recirc, or is it better because I have a bathroom over here and a bathroom over here and this fixture and that fixture? Is it better to do these TechXpress manifolds? So we have different options like that. So pay attention to that. These don't come with individual shutoffs though, and that's one good thing about the ManaBlock. But we do have shutoffs you can add if need be. But shutoffs need to be accessible per code, right?
Yep.
So if this is in a wall, this can be buried if it has no shutoffs. It can be buried behind a concealed location because it's just a fitting. But if you add shutoffs, now code says it needs to be accessible, which means you need a manifold cabinet cover or something like that, access panel.
So Troy and I are calling these manifolds, but technically it's not a manifold. This is a manifold because there's valves. This is technically a multi-port T, and that language can get you in hot water, no pun intended, because if you say the word manifold to certain inspectors in certain jurisdictions, they're going to want access to it. So if you know your jurisdiction, you're going to crack the code book, call this a multi-port T. That's what we called in our catalog. So, and Troy, you mentioned Radel R. What the hell's Radel R? Why do I care?
Well, maybe, some people might be like, I don't even know what it is, or I don't care, but why that's important, that's the quality, that's the polymer, the resin that we actually use to manufacture our PEX press and PEX crimp fittings, along with these multi-port Ts. And that Radel R is a high-quality thermoplastic that allows you to have better, let's say, you can have that hot water recirculation, right? It's better performing product. You can have 24/7 hot water recirculation. It's not going to break that plastic down. It's not going to hurt the plastic. It can handle the high heat. It can handle the cold. It can handle a dual temperature system. It can handle the tensile strength, the stresses. So Radel R is actually important to all of us in manufacturing because we're offering you a quality product. When a PEX manufacturer calls theirs an engineered polymer, you actually should be worried because an engineered polymer is a witch's brew of whatever resin they can get their hands on. And it's usually, I think, glass filled, right, Bo? Like they have a filler.
Per the standard for these fittings, it can be either non-glass filled or glass filled, and they can have a certain amount of recycled content back into the process. And we typically don't put a ton of our product because we have so few misfires coming off of our injection molding machines that we have well under the standards amount of recycled material going back in, which is if you have a mistake made on the fitting or your runners, which are all the little pieces of plastic that hold. If anyone ever did models when they were a kid and you've got all your little pieces on those wire frames and you snap them all out and you sand them off and glue it together. Well, the rest of that is called runner. It's all the same plastic, came out of an injection molding machine. And that usually goes back into the hopper, but it's a very, very small percentage. So yeah, Radel R is a really, really important plastic. And one reason it's really important to you is A, Viega uses it. We put quality first. We manufacture these in McPherson, Kansas. They're made 100% in the USA. And also, it happens to be the secret special word of the day, Radel R. Troy?
That's how you're going to actually win some swag. You want a TechTalk hat just like this? Go to @Viega LLC and go to the post where it shows Trainer Troy with a ManaBlock, that magic trick in the electrical panel, and I want you to put comments in there, Radel R. That's all you have to say. Just go to the comment section, type in Radel R, and for the first people, right, who first come, first serve, I'll start sending out some hats. So I'm not going to say how many. I don't, we'll put a cutoff to it. Maybe only a couple, maybe a few. I don't know yet, but first come, first serve. So jump in there, Radel R right here. But that's it. I just pass out some swag. But don't leave the show yet. Don't leave the show yet. Again, I'll do it at random. Maybe I'll do a raffle. Don't run off to get a hat. Maybe we'll do a raffle or a spin the wheel or something. But go in there after the show. I'll know if you go before the show. I got a timer. Go after the show and type in Radel R. So don't leave the show yet.
Awesome. So secret safety word is out now. Cat out of the bag.
Good.
So what about branch and tee, Troy? We all know branch and tee, right? We're all plumbers. We've all done stick fitting, heck, before PEX, or if you don't use PEX and you use copper or CPVC, stick fitting, right? So Radel R fittings, bronze fittings, branch and tee. Advantages, disadvantages in your mind?
No, honestly, again, it all depends on the application. Now, when you look at a traditional branch and tee system, and then you look at the manifold, the ManaBlock that is behind you, now the benefits to that ManaBlock is I'm going to get a better pressure balanced system traditionally, and I'm going to see a less pressure drop when multiple fixtures are running. It's very, very minimal. If a scientist or an engineer want to cross hairs and sharpen their pencils, there is obviously a pressure drop, right? But a traditional branch and tee systems, you have to go in sequential flow. You start at your water source and it flows down and it tees off to all your fixtures. So if I have a shower running over here, that water's flowing. And then if I want to rob some water in a branch and tee system to run fixtures down here, I actually rob that water a little bit. And if a system's not designed properly, you actually see pressure drop and temperature drop in a traditional branch and tee system. The ManaBlock alleviates that, right? It's a better system for that. But if there is a properly sized branch and tee system, you're going to have some benefits there too. So again, what are you looking at? What are you looking for? Because I will tell you, a branch and tee system is more cost effective when it comes to the price of the material, right? Again, depending on size and layout, because you got to think it's stick tubing, right? I'm going to get my sticks of tubing. I'm going to sling it up. With a ManaBlock, it's added cost because you have home runs to every single fixture, so it's more tubing, and then the cost of the ManaBlock, but you have a better performing system, right, with that ManaBlock overall.
And less fittings too.
And less fittings behind the wall, right? You should only have connections from the ManaBlock to the fixture, nothing in between. So that's great too. I don't have to worry about fittings in concealed locations, right? Because at the end of the day, yes, PEX Press fittings, they're bulletproof. PEX Trip bulletproof as long as you did it right, right? So again, I'm not concerned about having fittings in the wall as long as they're installed correctly. But that is something that, is nice to not have a fitting. So I alleviate the cost of the fittings and things like that. So there's a lot of back and forth of which one I want to go with. And for me, it's looking at those customers' needs and the layout of that building.
One cool thing that you can add in your plumbing business or your mechanical business or whatever you have is you can add that as a choice. You can say, well, we offer this system. We offer multi-port T system with recirculation, and there's ways to balance that. I'll cover that real quick. And you can offer a branch and T, and you could have good, better, best, or you can price that accordingly, because in some cases, all three may be applicable, and it gives you added value. And I promise you, your competitor's probably not doing that. And it's just that little bit of extra value that you've put thought into your business that the customer's gonna be like, you know what? This company kind of seems to know their stuff. They say that I think I want them, and they're 30% higher, but you know what? I think it's worth it. And you know what? That's not a bad thing. That's not a bad thing. So keep that in mind. There's other ways to add value to your system. Troy was talking about about recirculating. So I'll just show you real quick, and I'm going to move the camera around. So everybody hold on. We're all going to get seasick here.
Blair Witch Project. Oh.
Blair Witch Project. So behind me, you can kind of see, you can see the water heater, and you see that recirc line hanging down. We haven't hooked it up yet. We're going to put a circulator in there, and we're just circulating between this point on the block to the water heater. So if the water heater were further than 8 feet away, I want to make sure I have hot water at the block. So the only uncirculated segment is right here. And of course the block itself, right here. And I have hot water up to this point. So when you open a fixture, you're just dumping very little cold water, and you're flushing your line of your cold water. So with these systems, you can put multiple manifolds out in a system, and you can have manifolds over on one side of the building, could be 100 foot away developed. And then you could have manifolds over here that are 45 feet away, and you can run a recirc line to both of those manifolds or all of those manifolds. The challenge comes in when you bring all those recirc lines back to your hot water source, your water heater. What are you going to do? How are you going to balance that? Well, again, design services comes into play. We offer a thermal balancing valve. You can put those thermal balancing valves in with a smart pump, like a ECM, electrically commutated circulator, on a timer with an aquastat. And as those lines cool down, the valves will open, the pump will see that pressure drop, and it'll begin to circulate again or increase its speed to provide hot water based on that time cycle. So these become very easy to circulate to or recirculate to, and also balance. So there's a lot of really cool solutions for that. Branch and T, you're typically going to the farthest end of the line that you're hitting all those branches. In some cases, if you've got an exceptionally long branch, you might have to recirculate that line as well and merge the two together. You can also use the thermal balancing valve. So there's a lot of really cool ways to get circulation in your system so that when your customer opens the faucet, hot water's coming right out. And there's nothing I hate more than waiting for hot water like 2-3 minutes, because look, at the end of the day, I am impatient. I want the water there, but most importantly, water is our most precious resource. Absolutely, hands down, most precious resource, that and air. But we got some air.
We got air,
dirty air, but it's air. But water's a precious resource. Don't waste it. If you don't have to waste it, and your customer will appreciate that. Again, value add. So keep that in mind.
Absolutely. No, that's great. And we got a couple of great questions on here that I want to shout out. And one of them is, the question was, do you need to upsize when using a PEX system? And for me, that's not an easy question to answer. You don't just say yes. You can't just say no, because that's where design service comes in. And as a designer myself, I'm looking at, well, what's the fixture? How far away is it? And what's my pressure? How much pressure is available? How far am I going? What is the operating pressure of that system? What's the volume is needed to operate that fixture? And that's going to be able to tell you. So I know where that question leads, because I get it all the time, because some people are ripping out, maybe they're doing a repipe, and they're ripping out copper, and they're replacing PEX. You shouldn't just swap PEX and copper apples to apples. And I don't care which PEX system you're using and what marketing fluff is out there. You should size the system properly, because sometimes you can get away with swapping it out apples for apples, size for size, and you may not see an issue. The other thing, though, is dependent, again, on that demand of that fixture. You might need to size that differently. So if you're not going to do the math, yes, the rule of thumb is always upsize by 1. but sometimes that's wasteful. You just talked about water conservation and so now you're just being wasteful. But again, if you don't want to sit down and crunch the numbers, yes, always upsize by one size, because here's an example. 2-inch copper gives you 75 gallons per minute. 2-inch PEX, 50 gallons per minute, right? So now there's feet per second, there's velocity associated. See, that's why there's a whole chart of what's the velocity and what volume can I get out of that pipe, and what's the pressure drop. So really, it's not an easy yes or no. But if you don't want to do the math, if you just want to, be lazy and get something done, to save your butt so you don't get a call back, upsize by one size. So it's 3/4 copper, go 1-inch PEX. If you're using PEX for a T&P valve, upsize. So PEX is approved for a temperature pressure relief valve on a water heater. But because the internal diameter is different, the way the code reads, you need to be 3/4 of an inch. So in order to do that, now I need a 1-inch PEX line on that T&P. So just, again, it's all code. Sorry, Bo, you were about to say something.
No, it's great. One thing to add to Troy's point, do the math. It's not difficult math to do.
Do the math.
You may find, especially a repipe, that's what perked my ears up. If in a repipe situation, you got 1/2-inch copper going out to a fixture, it might be a shorter distance. You might be able to fish 3/8.
Yeah.
If you size it, and you might be able to pull right back through the same holes with a fish tape and pull your 3/8 right through it and not have to open drywall. Again, value add. So it's worth doing that little bit of mental gymnastics, and it's not hard math. It's multiplication and division. And you can, you may be able to save yourself having to go back with 1/2 inch. You might be able to downsize. So it's worth taking the time. So
definitely worth it. Do the math. Do the math. Do the math. Do the math. Your customer will be happier.
Yep. And we have a team of people to help you with it too. So don't be afraid. So we have a PEX design manual. You can download it on our viega.us website, and you can see the calculations there. It's very simple. So one last thing real quick. I promised to point this out. Troy was talking about building pressure, and I just want to hit it.
Yeah.
If you've got a water heater in your building, could be an indirect fired water heater, could be a tankless water heater, especially if you have a recirc line on that tankless system, could be electric water heater, direct gas fired water heater, whatever it is. When you heat that water, it's going to get bigger. It's going to take up more space. Water does not compress easily at all, okay? And because it doesn't compress, you need somewhere for that additional pressure to go when the water expands. So a thermal expansion tank is almost always going to be required in any plumbing system if you have an incoming lateral that is, say, going to fluctuate higher than 80 PSI. So now you're going to basically thermal expand. Your water pressure is now over 80, even though you've regulated it, because the regulators allow backflow, okay? Or if you have a check valve or a backflow preventer on the building, you can't flow backwards. So make sure you understand what's in your system, because you should have a thermal expansion tank, and that will stabilize your pressure. Look, a 2-story home, okay, anywhere in the country can function at 45 PSI incoming pressure, okay? The other one that drives me bonkers is that I'll see contractors, they'll build homes, and they'll tie in the irrigation system upstream of the PRV and feed the irrigation system in the yard with like 100 to 150 PSI, okay? Well, most irrigation rotors and just sprays operate at 15 PSI. So why we're putting 10 times the pressure to our irrigation heads, I have no idea. But if you want to save water and see a lower water bill during irrigation season, go size your system, and you'd be really surprised what you can do with, 50 PSI going out to your irrigation system. Obviously, if you've got a yard like Troy's, you might need a little bit more. He's got some land, but I have a little tiny podunk backyard, and guess what? I need like 30 PSI to irrigate my yard. So pressure is important. Pay attention to it and know where to apply a thermal expansion tank so you don't overpressurize your system when your teenagers drain the tank down to 50 degrees, and of course you get a cold shower or no shower, and while that water heater is reheating, you expand the water in the system and put undue pressure on your ManaBlock, on your manifolds, on your fill valve, on your toilet, on your ice maker solenoid valve, on your refrigerator. They're made of plastic. We don't need that kind of water pressure, so think about that, and it's a value add.
That's a great value add. That's a great soapbox. I'm glad you stood on that soapbox. One thing, I don't do lawn irrigation. I rip my quad, my 4-wheel around my house all the time. I don't care about green grass, right? So I don't even care. And we're in the sticks. We're up on a hill. Nobody can see it. I don't need to keep up with the Joneses. But that is actually a great tip for water conservation. So I'm glad you stood on that soapbox. I see we're 6 minutes away from the end of the show. One thing that I do want to actually say, so you could actually see, there's going to be a technical advisory coming from our tech team on PEX. And because of the pandemic, there's been some projects that were shut down. And those projects were shut down probably back in February or March, and they may be opening back up now, or not even now, later on. Please keep in mind that all PEX products, look at their UV rating. I don't care if it's Viega or anybody else. Look at the UV rating on that tubing. It's a print line right on the PEX. Make sure that it was either covered before you left the job site and protected from UV light, because Viega PEX is rated for 6 months of UV. So we have a 6-month UV rating that's the highest per the standard, per the performance standard that is tested to, which is great. But if you exceed that, if the fittings exceed, they say 15 to 30 days. Again, there's going to be a technical advisory that I'm drafting up with our team with product management right now, because we just want to warn you. If it's been out there, just inspect it. Give us a call. We'll work with you, because we want to make sure that everything's good, safe. You're not turning on stuff that may have an issue. So whether it's me or a competitor, look at that UV rating, because if a job was shut down, PEX was unprotected, again, it's plastic. You want to protect it from UV light for long-term exposure. So again, our PEX tubing is 6 months of UV. It's the highest per the standard. And with that, awesome. I'm going to say thank you so much, Bo. Love the install. I hope everybody tunes into our next episode. Our next episode, which is episode 9. I can't believe it. Our next episode, I'm checking the date right now, October 21st at 6 p.m. Central. And we're going to have a special guest. I don't know who yet, or maybe we do, but we will tease you. So follow at Viega LLC. Follow at Trainer Troy. We'll drop some hints in there, but check it out. This was great, Bo. Thank you very much, man. Anything else to add before we hop off this?
If you got any ideas for future episodes of Tech Talk Live, you can email Troy and I at techtalk@viega.us. Again, it's techtalk@viega.us. And please don't forget to follow us. Click the link, subscribe, follow us at Viega LLC. We love having you. One last little value add. It's getting frosty in the northern latitudes. You want to add some value for your customers? Send out a postcard reminding them to disconnect their garden hose from their outdoor spigots. They will love you for it, and they will remember you always. Just a little fun tip from me, a little bit more value. Other than that, we loved having you. Thanks for showing up, and we'll see you again soon.
Hey, thanks, Bo. Appreciate you, brother. This was a great show. I'll see you on the next one.
Back at you, bud. All right, see you soon.
See you later.
Bye.